Hello, this is Mr. Stansbury. I'm going to take you through the notes on similar triangles. At the end of this, you should be able to say, I can use the properties of similar triangles to show that triangles are similar and to find missing measurements of similar triangles. All right, so quick little review, just like the section before this one. Two triangles are similar if either they are equal angular, so all the angles are, all the corresponding angles are the same, or if their side lengths are in the same ratio. Okay, so let's look at some examples. Example 3, show that the following figures possess similar triangles. All right, so we've got all these here. So once we, so basically, remember, it's either show that all the angles are the same, or that all the sides are the same ratio. So if you'll notice right here, we've got that this angle and this angle are the same. That's what that's saying there. We also know that this angle here and that angle there are the same from good old geometry, right? Okay, what vertical angles. So we know that those two are the same. So if we have two angles that are the same in two different triangles, then we know that the third angle then also has to be the same. Here, let's do this instead. Let's do the little, that's got singles, that's got doubles, and this one will do 3, which will show that that is the same as that. So therefore they are similar. Therefore similar triangles. Okay, and it'd be wise to actually name these similar triangles. So let's do this. Triangle ABC is similar, which is shown with a little single squiggle there. So triangle ABC is similar to triangle. And so A is the one that starts with the 3, the triple. So we know that A and D are the same, are the corresponding angles. So we're going to start with D. And then let's see, B is the single one, and that's E. And then C is the same on both of those. Okay? So triangle ABC is similar to triangle DEC. All right, moving on to this one here. So show that these are similar triangles. So basically what we have here is, if we're to redraw this, we have two triangles. We have ABE and ACD are the two different triangles, right? So let's do this. We've got, I'm just going to redraw both of these so we can kind of compare them to each other. Okay, that's close enough. So smaller one is A, B, E, and the bigger one is A, C, and D. Okay, so A is the same in both, so we know for sure that A is the same as A. Okay, and now we know that these are parallel. Okay, so B, E, and C, D are both parallel lines. Okay, so since they're parallel, we know that this angle, since it's coming, they both are using this same side here, this angle here has to be the same as this angle here because these lines are going down at the exact same slope. Okay, so we know that this angle here, B, has to be similar to angle C. Okay, and then again we've got 2 of the 3, so then by default D has to also be the same as E. Okay, so these are similar triangles, and that would, let's do triangle ABC, oh sorry, ABE, there, look, and is similar to triangle ACD. All right, now let's try this one here. We've got ABC and EDC here. We've got these two triangles here. So we know for sure if this is 60, this up here has to be 60. Okay, it says that this is 57 right here. We know that all three of the angles have to add up to 180, right? So 57 and 60 gives us 117. We know that it has to add up to 180, so then we can take 180 minus 117 gives us 63. So this is 63, and that's 57. Look, this is 60, 63. Guess what this one's going to be? If you had to do the math, 60 plus 63 is 123. 180 minus 123 is not 117, but 57. Getting a little ahead of myself there, 57. And we also could know that for sure they have to be the same since the 60 and the 63 match, the 60 and the 63 there. Then we know that the triangles have to be similar. So, similar triangles. Oops, similar triangles. And then let's do triangle. Let's go ABC. Is similar. Now we got to get the ones that have the same angle measure, 57. So we got to start with D. And then B is the 63. So the 63 on this one is E. And then C is the last one on that. Okay. Oops, forgot the little triangle symbol there. There we go. Okay. Last one down here. So we've got ABD and BCD. Okay, we've got to show that those are similar. Okay, so we've got these parallel lines, so that's going to help. Okay, so let's redraw these like we did these up here. And it appears that A and C are going to be the same. So I'm just going to take this one and kind of rotate it around and put it right underneath BCD. So should look something. Okay, it's a little off, but that's all right. Well, close enough. Okay, so this A rotates all the way down over to here. Okay, and then up from A, the short side is D, and then the last one is B. Okay. Probably the easiest way to do this is to say, so these are excuse me, parallel lines right here. These are also parallel lines here. So we've got this transversal thing, so we know that this angle here, across the transversal and down the other corner, those are going to be the same. These here are also going to be the same, and then by default these have to be the same. Okay, so these are also similar triangles. Oops. Similar triangles, and so we've got triangle. This is nice because we redrew it already, so let's do, say, BCD. So triangle BCD is similar to triangle DAB. Right? DAB. Okay. One last set of examples here. Just one last example, and then away we go. So, establish that a pair of triangles is similar. Hence, find x. So, just a quick little note: whenever you see the word "hence" in the IB, that means take what you just figured out and use that to help you find something else. That's what the hence means. So. This one is pretty similar to the first example we did on the last page, so let's do this. Let's redraw this. So here's our A, B, and E, right? And then underneath it, we'll draw the bigger one. There's A, C, D. Okay, so A, B, E, and then this one is ACD, A, C, and D. So we know that on this small one, we got AB is 10, AE is 14. We do not know what BE is. On this big one, we know that AC is 10 plus 4, so that's going to be 14. And on the smaller one, we've got that A to D is 14 plus X. Okay? Okay, so we know that angle A has to be the same as this angle A. Since, again, these are parallel lines, these angles here, here, and here have to be the same. So that is this and this. And since we have two of the three, that means by default the last angle also has to equal, has to be the same measure as the other here. Okay, so we've now established that the pair of triangles are similar. Now find X. So now we're just going to set up a ratio, right? So let's go, say I'm going to do the AB side. So that's 10 is to 14 should be the same as 14 is to 14 plus X. Okay, now we can just cross multiply. And then away we go. Okay, so let's bust out our calculator here. And let's see, we got 14 times 14 gives us 196. And that's going to equal 10 times 14 is 140 plus 10x. Oops. So just got to solve this one. Subtract 140 from both sides. And we're left with 56 equals 10x. Divide both sides by 10, and we get that x is going to have to be 5.6. And they don't give us any units, so we'll just leave it as that. Okay? All right, that's all there is for this section here on similar triangles. If you have any further questions, please feel free to ask in class. Thanks.